think about all the things you do with your hands every single day. Scrolling on your phone, turning a key, waving hello. Your wrist is always on the move. And it seems so simple, doesn't it? But packed inside that tiny, flexible joint is an absolute masterpiece of biological engineering. So let's dive in and see how this amazing piece of machinery actually works.
I mean, really think about it. How does your wrist handle all of that? How could it be so incredibly strong one moment and so delicate and precise the next? Well, we're going to go on a little journey deep inside the wrist to uncover the brilliant structures that make it all possible.
Now, you might think our story starts right at the wrist joint itself, but actually, we need to begin just a little bit higher up, with the two bones in your forearm. This is where the whole magic of twisting your hand really begins.
Okay, meet the radius and the ulna. These two bones run side by side all the way from your elbow down to your wrist. But look really closely at where they connect, right near your hand. That little spot is called the distal radioulnar joint. And this joint isn't about bending your wrist up and down. No, its whole job is to be the crucial pivot point, the axis that allows your entire hand to rotate.
And that pivot enables two really important movements, pronation and supination. Pronation, that's when you rotate your forearm to turn your palm down, like when you're typing. Supination is the opposite, turning your palm up, like you're holding a bowl of soup. You can remember it by thinking soup-ination. Every single time you turn a doorknob, you're using this incredible pivot.
All right, but a pivot point is pretty useless if it's all wobbly and unstable, right? So now let's check out the incredibly complex structure that's job is to hold this whole system together and basically take all the punishment you can throw at it.
And that structure is called the triangular fibrocartilage complex, or just TFCC for short. It sits over on the pinky finger side of your wrist, and honestly, it's the unsung hero of this entire setup. Think of it like a high-tech hammock made of tough ligaments and cartilage that gives your wrist stability and absorbs shock every single time you push, pull, or fall on your hands.
And here's what's so wild about it. The TFCC isn't just one single ligament. Oh no, it's a highly sophisticated system made up of 6 distinct interconnected structures, all working together in perfect harmony. 6.
Now, the absolute star player of the TFCC team is this part right here, the articular disc. See that dense little pad nestled right between your forearm and wrist bones? That is your wrist's #1 shock absorber. It's this tough yet flexible piece of cartilage that takes all the force coming up from your hand and transfers it safely to your forearm, protecting the joint from all that impact.
So to put it all together, the TFCC is a total workhorse. It's absorbing shock, it's keeping the pinky side of your wrist stable, and it's creating this nice, smooth surface for your bones to glide on. But most importantly, it stabilizes the very pronation and supination movements we were just talking about. It's doing everything at once.
And this is so cool. You can see exactly how it works. When you turn your palm up, that's supination, one set of ligaments tightens up to provide stability. Then, when you turn your palm down, pronation, another set tightens up on the other side. It's this perfect, dynamic push-pull system that gives you controlled, stable rotation. Just an incredibly elegant piece of design.
Okay, so we've got bones that pivot and a complex that keeps them stable. But what about all the wiring? How do you manage all the tendons and nerves that have to snake their way through this super crowded area to actually make your fingers move?
Well, the answer lies in these two brilliant structures, the flexor and extensor retinacula. The easiest way to think about them is as super strong fibrous straps. You've got one that goes across the palm side of your wrist and another that goes across the back. Their job is to hold all those long tendons down, keeping them from popping up like a bowstring every time you make a fist. Let's zero in on the one on the palm side for a second, the flexor retinaculum. You can see it here, stretched super tightly across the small carpal bones of the wrist. Now, it might just look like a simple strap, but what it creates underneath it is probably one of the most famous pieces of anatomy in the entire human body.
And there it is. By forming a roof over the natural U-shape of the carpal bones, this ligament creates the carpal tunnel. This is that critical passageway for just about everything that makes your fingers and your thumb work.
So what exactly is packed into this incredibly tight space? Get this, 9 different tendons that are responsible for flexing your fingers and thumb, plus one incredibly important nerve, the median nerve. It is a masterful piece of anatomical packaging, but you can also see why it becomes a problem if things in there start to get swollen. All right, we've covered the pivot, we've covered the stabilizer, and we've covered the tunnels. So, it is finally time to meet the star of the show, the joint that gives your wrist that amazing range of motion we all rely on.
This right here is the radiocarpal joint. This is what most of us picture when we think of our wrist joint. It's the meeting point between the big radius bone in your forearm and the first row of tiny carpal bones in your hand. This is the joint that lets you do all the classic wrist movements, bending it up, down, and side to side.
More specifically, it's the connection between the radius and these three specific carpal bones, the scaphoid, the lunate, and the triquetrum. The way their complex shapes fit together is what allows for the smooth, gliding movements that make our wrists so incredibly dexterous.
So let's just take a step back and pull all of these amazing pieces together. You've got a pivot for rotation, a complex stabilizer for shock absorption, these clever tunnels to manage all the tendons, and a main joint for all the bending.
When you really look at it all at once, the wrist is nothing short of an engineering marvel. It has to perfectly balance this incredible need for mobility with the serious demands of strength and stability, and it does it all within this tiny, compact space. It's just amazing.
So, the next time you pick something up, turn a page, or just give a simple wave, maybe you'll have a new appreciation for the incredible, intricate dance of bones, cartilage, and ligaments happening just beneath your skin. What part of this amazing little machine will you think about?